A key component of the modern world economy, the chemical industry delivers products and innovations to enhance everyday life. It is also an industry in transformation, where chemical executives and workers are delivering growth and industry-changing advancements while responding to pressures from investors, regulators, and public opinion. Discover how leading companies are approaching these challenges here on The Chemical Show. Join Victoria Meyer, president of Progressio Global and host of The Chemical Show, as she speaks with executives across the industry and learns how they are leading their companies to grow, transform, and push industry boundaries on all frontiers. Here's your host, Victoria Meyer.
Hi, this is Victoria Meyer. Welcome back to The Chemical Show. This week, I am speaking with Peter Hanik. Pete is the president and founder of Pretium Innovation, which specializes in intellectual property and team-based innovation systems to create sustainable value. Pete's got a long and deep history in the chemical industry. He was president of technology at Reliance Industries in Mumbai. He's also held a number of technical and senior management positions at Millennium Chemical. And Pete and I we've been a little bit like two ships passing in the night. Our paths have crossed from a company perspective. We're both graduates of Illinois Institute of Technology. Pete's a bit of a crosstown rival with his MBA. He did his at University of Chicago. I did mine at Kellogg, but nonetheless, we actually have a lot of similarity in our background. So anyway, Pete, I am really glad to have you here and welcome to The Chemical Show.
It's a pleasure to be here. Thank you.
Excellent. And so let's just start with, what's your origin story? What got you interested in the chemical industry and what led you on your path?
Well, right out of high school, I went to IIT, as you mentioned. I was majoring in physics. Second semester in school, my father passed away. I had to drop out for a while and go to work. And it seemed like the only jobs I could get were in the chemical industry. So I sort of naturally gravitated over to that. A number of my employers would sponsor my education as long as it related to chemicals. So I switched to chemical engineering. And then I had a number of jobs while I was in school. And then when I got out of school, I went to work for Northern Natural Gas in Omaha. And then I went to Northern Petrochemical, their petrochemical division. That became Enron Chemical. Then that became U.S. Industrial Chemicals, and that became Quantum Chemical, and that became Millennium Chemical. And so
that business sure went through a lot of ownership changes.
It did. So
yeah.
I worked for the same company for 30 years, and I think there were 6 different company names on my business card.
That's crazy.
But the whole time it was an interesting transition, because when I first started, it's kind of like the industry was all about new products and new processes, and there were lots of new things going on. And then in the 90s, it seemed like the focus shifted to cost reduction. We were trying to lay people off, headcount reduction, felt we were trying to save our way to prosperity, which wasn't as much fun as innovating and doing new things. Well, in 2003, Lyondell bought Millennium Chemical Company, and I was the chief technology officer at the time. So along with all the other executive staff, I left.
Yeah.
And I decided, rather than try and find another industry job, I'd like to help companies recapture the ability to innovate and come up with new intellectual property. And that's when I started Pretium Innovation.
That's interesting.
Yeah. So
I think I'm going to jump in here, because I think your point on that the chemical industry was very innovative in its early days, and somewhere around the 90s, like, we lost our will to innovate. Mm-hmm. I certainly saw that.
Yep.
And it took a couple decades before companies got back into it. Would you agree?
Yes. And I think we're back into it today. We've kind of been beaten into it by the need for sustainability and energy reduction and green energy and so forth. I think that the world has sort of reinvigorated the idea of innovation, because that's what people seem to be talking about and focusing on. So that's great.
Yeah. So you left Millennium and you decided that you were going to add value to the industry at large. And then you
Yeah.
decided to join Reliance, or maybe it wasn't that simple of a step.
Well, yeah, I had been running my own consulting software business for almost 10 years. And I had some conversations with Reliance about doing some work with them. And the fellow I was talking to said, you know, what you really ought to do is just come to work here. And I said, well, India, I don't know. And so I went there and talked to him, and it seemed like a really exciting opportunity to take my industry experience and what I learned about creative problem solving and apply it. So that's how I became president of technology there. You know, when you look at my career and the jobs I've had, being CEO of a chemical company and CTO and so forth, some people might say, well, you're a pretty successful career. And I'd say, well, yeah, certainly in one measure. And I'm happy to tell you the secret to that success. It's
I'd love to hear that. I know others would as well.
Yeah. Always surround yourself by people who are smarter and more creative than you are. It's guaranteed to work. So, you know, when I left Millennium, I had worked with a lot of creative and smart people. So I started to study. Some of these guys could come up with really creative problem solutions. And I started talking to them, and well, how did you think of that? And I concluded that in a lot of cases, they would look at a previous problem they solved or one they read about, and they could think about that solution abstractly. And then they would take that abstract solution and consider, how could I combine that with resources in the current system that contains the problem I'm working on? And sort of the synthesis of that and abstract problem solution and resources I have available leads to an idea. And then, you know, the ideas get tested, and the you know, the good ones can be potentially implemented. What I found by doing that in a structured way, I developed a kind of a process that models that, and that people would come up with 10 times more ideas using the structured approach than just sort of sitting around the table and brainstorming.
Yeah.
So Linus Pauling, you know, the chemist who won the Nobel Prize, he once said, if you want to have a good idea, have a lot of ideas and figure out which ones to throw away. So that's kind of what I've tried to do.
Yeah. So that's interesting. And that's what brings you to type 3 solutions. Is that right? Is that how you categorize that? I know you've written a book, Type 3 Solutions, and you've applied this. Yeah.
And I've said there are 3 basic kinds of problems. You know, a type 1 problem is solved by inspection. I see the problem, I know the answer, I just go do it. A type 2 problem is an engineering problem. I understand the problem, I don't know the solution, but I know how to get it. And then a type 3 problem is one where I may or may not fully understand the problem. There may be some solutions that are insufficient, or there may be no solutions at all. So the number of problems that we face tend to be mostly type 1 and 2. The number of type 3 problems are small, but solutions to the type 3 problems often lead to breakthroughs in performance. So that's what I focused on, and how did the people I knew come up with those solutions to those kinds of problems?
Yeah. So if you look around us at today, at the business environment that we're in today, what would be a type 3 problem in need of a type 3 solution?
Well, it might be easier to give you an example of one in the past.
Sure. Bring it on.
When I worked in the polyethylene industry, as I know you did, when you make bottles for things like detergent, for high density polyethylene bottles, they need to have a combination of properties. One property is stiffness. You know, the bottles have to be strong enough to be stacked up. The other is stress crack resistance. The detergent tends to crack the polymer. The way you get stiffness is with higher molecular weight. And the way you get stress crack resistance is with lower molecular weight. So how can you
That's
have
a
both?
dilemma.
Yeah. So the solution was one of these innovative abstract principles. One of the principles is separation. Can you form a separation such that in one case you get the good thing and in the other case you counteract the bad thing? So 2-reactor systems are used today to make these resins for detergent bottles. The first reactor produces a high molecular weight polymer, and then that polymer is transferred to the second reactor. And in that reactor, you produce a low molecular weight copolymer that provides a stress crack resistance. So you can get the proper balance of the two.
Yeah.
You can do it in one reactor, and some companies have developed bimodal catalyst systems to do that. But that was an early example of an innovation that was a transformative one for many companies.
Yeah, it sure is. And I know that bimodal has become a really big deal in high density polyethylene in particular to solve a lot of these problems. And I think what's interesting, in fact, where I thought you were going to go with this, Pete, was around multi-layer products, which of course is another approach to that solution, right? So you have an inner layer that reacts in one way and an outer layer that provides different properties, which we certainly see a lot in film in particular.
At one point in my career, I was director of applied research and technical service at Quantum Chemical.
Yeah.
We decided that we wanted to participate in the multi-layer high-performance barrier packaging industry. And we made polypropylene, polyethylene to the base resins. So then we also developed tie-layer resins, adhesives, extrudable adhesives. And we formed a joint venture with Carrare to make EVOH barrier resins. And then in my department, the Applied Research Group, we did a lot of work to building structures that could provide oxygen barriers and other kinds of performance. So, and that was kind of a strategic innovation to do that. Most companies focus on the product they're selling. Well, we sell polyethylene, but the customers don't care about your product. Give you a simple example.
I completely agree.
When I was a kid, I played music on a phonograph. Now, the value engineers for over 60 years have done function analysis, and they say a function is a verb and a noun. So the primary function of a phonograph is to play music. But then after phonographs, we had tape players, primary function, play music. And then we had CD players, primary function, play music, and then iPods and iPhones, primary function there, play music.
Yeah.
The difference is that each of those successive technology advances eliminated some of the harmful functions that delivered the primary function. And when that happens, when a new design or technology comes along, it eliminates some very big harmful functions that limit functionality. A paradigm shift occurs. So nobody plays music on phonographs today, but the reason they buy an iPod or a CD player is so they can play music. They care about the function, not the product. And that's basically the same whether it's a process or a product. So one thing that I think chemical companies should consider is, do I want to just sell the product, or can I sell more in terms of functionality?
Yeah.
So a story about this, when I was director of applied research, Philips produced high-density polyethylene for milk and water bottles. The number one product character there was organoleptics, taste and odor. The resin shouldn't impart any taste or odor to the milk or water.
Right.
So, and we wanted to get more of that market because it had pretty good margins and it was growing. So we set out to develop a resin with the best taste and odor properties in the industry. And we did it. We had taste and odor panels and data. We could share that. We sent our marketing and sales guys out to say, here, we got the best product. And we couldn't get people to buy it, very little. I'm scratching my head saying, well, why wouldn't somebody want to buy the best product? We even offered a discount so they wouldn't buy the best product at a lower price. Well, as I mentioned, Philips had the largest market share in that market. And what we came to learn was that when you blow mold a bottle, As you run that blow molding machine faster and faster, the polymer will melt fracture. It's like little wrinkles as it goes through the extruder. And when that happens, you have to slow down.
Right.
So, and everybody knew about that. And if you tried to find a way to change the polymer to reduce that melt fracture, it tended to affect the taste and odor properties negatively. Well, Philips found a way to design a die for a blow molding machine. And that die that had a longer land length, basically. It allowed time for the rheological stresses to settle out in the polymer, and you could run faster with any polymer using the Philips die design. And they have several patents on that die design from back in the 80s. And if you were a customer of Philips, well, for $1 or something, you got to use their die design, which meant a lot to the customer because it helped them get more productivity from their business. And it was so significant that you couldn't buy volume away from Philips. So their offering was not just the polymer, it was the polymer plus the extrusion technology.
Yeah.
In fact,
It's
their
interesting.
polymer didn't have the best taste and odor, but it was good enough.
Good enough. And that's right. So I think we've lost, I talk to companies and customers about this regularly, that your customer doesn't really care about your product and your price. They do, right? It needs to be good enough. The price needs to be good enough, but there are other reasons why they're making buying decisions and use decisions, and you have to figure out the why behind it. In this example, it's about the use of the die and the fact that they could run steady. In fact, the whole ability just to be able, especially with polymer customers, to be able to run without having to change the machinery and make adjustments on the machinery is significant, right?
Yeah,
and that's true across the way. And so you have to be able to, as a company, as a salesperson, as a product person, as an innovator, go a little bit deeper, understand what's really important, why they do what they do today, and how you can overcome that so that they buy from you. Because again, the best product and the best price alone is not the reason.
Right.
If it was best price, we would all be flying Spirit Airways, and we're not. So,
when I was CEO of Millennium Petrochemical Company, we made acetic acid and vinyl acetate, commodity chemicals, and we increased our market share against our competition every year for almost 5 years running. We did that by providing better customer service. We really empowered our customer service people to do more for the customer, and that built some loyalty with them and with our customers. And there was no price difference because it was really a commodity chemical. But the Philips example is different in that it's based more on innovation and therefore more sustainable. Philips had patents. Patents are good for 20 years.
Right.
So they could carry that on for quite a while. Now, today, there are lots of opportunities like that in the chemical industry. But one in particular, I think, relates to sustainability. As a chemical company, we have sustainability issues, and our customers do.
Definitely.
So, just like Philips understood the function, how the customer got functionality from their high-density polyethylene, if you understand how your customer gets functionality from your product and what are the limitations on that, what are the harmful functions that limit that functionality, you may be able to come up with offerings that will give you a sustainable advantage.
Yeah.
And as I said, that they could be things like cost in the Philips case, or they could be sustainability or environmental, which today are kind of hot buttons.
Yeah,
So,
absolutely. I think the whole aspect of understanding that some of your customers' decisions are driven around sustainability in particular, and ESG and circularity, right? In the plastics world in particular, this is a tremendous driver. And it's really easy to say the quantities of circular plastics, for instance, that are being produced today are nominal compared to the rest of the volumes being used. However, figuring out how to create that circular material or the sustainable material, if you want to call it that, and bundle it in with the rest of your purchasing, creates pull through. It creates opportunities. It creates a different dynamic and a different reason for people to buy from you.
Yeah. Well, the big thing on that today is recycling, right? So, and my wife and I recycle. We put everything and separate it out, and it's all well and good. It makes some contribution, but I look at recycling from the standpoint of entropy. So when you start out, you've got pure materials. You've got polyethylene, polypropylene, this material, that, and when you make them into a product and then people throw them away, there are a whole bunch of things mixed together in the recycle bin, right?
Yeah.
So entropy is a measure of the degree of disorder in a system. And that can, with all those recyclable materials, different plastics, metals, cardboard, paper, the entropy is very high compared to what it was when they were all separate and organized. So the real problem with recycling is you're fighting entropy. And fighting entropy is almost always a losing battle. So there needs to be new ways to look at circularity and sustainability in polymers in particular, and chemicals in more broadly.
Yeah, interesting. And I know we started out talking about the type 3 solution framework. Does that provide an approach to solving that problem of entropy, to helping with the circularity and recycling challenges that we're having, do you think?
Yes. In general, I think when I designed this, you could use it as an individual. But what I really wanted to do was to make it a team activity. And the approach of first defining the system that contains your problem. And you have to understand cause and effect in the system that contains the problem. Otherwise, all you can do is guess.
Yeah.
So function modeling helps us understand cause and effect, because function models show how, why, when things happen. Then when you've identified, and typically you'd identify a number of problems in a system. So you pick the high value ones and then use the structured brainstorming method of how the natural creative person does. You take an abstract principle, combine it with resources to come up with ideas. And if you do this in a team, as I said, I did one project with a refinery here in Houston about a hydrotreater catalyst, and they came up with over 200 ideas how to increase catalyst life. So
yeah,
a lot of
amazing.
them, some of them were not practical, but in that there were a couple of
some gems.
Right.
Yeah.
So yeah, so I think it does apply very broadly to these kinds of problems. As I said, it's type 3 problem is one where there may not be any satisfactory solutions. So if a team,
I'm gonna turn the conversation a little bit. I know that you spent a number of years working in Mumbai.
yes.
And how did the problems or the approach to strategic and type 3 problems differ? Do you see a very dramatic difference in, number one, the type of problems that you were facing, or two, just how teams inherently approach those problems?
Well, I think the problems were very similar, because Reliance is both a refiner and a petrochemical company, among a lot of other things.
Yeah.
And my job, I was president of technology, so I had the R&D groups under me. Well, there are cultural differences between the US and India. In the US, if you try to be the autocratic dictatorial manager, I know best, I'll give you the answer, you just go do it. That doesn't work. The team
Right.
members are just not going to put up with that. They'll leave or whatever. But there's more of a culture that way, hierarchical in India. In meetings, people will tend not to challenge a manager. And the higher up the food chain the guy is, the less likely they are to say anything. I used to joke that if a manager there said, well, I want you to go outside before sunrise, set up a table looking to the west and look to the west. And when you see the sun come up, write down the time. Now, you might know the sun comes up in the east, and you might say, well, sir, I think you just misspoke. I'm sure you know the sun comes up in the east and I should face the east. People wouldn't say that. They would go and look to the west and they'd record, well, I didn't see the sun come up. And their philosophy, their thinking is, as long as I do exactly what I'm told, I can't get in trouble.
Mm.
Now, that's obviously not everybody, but there is a bit of a cultural inclination toward that. And I found Indian companies were much more hierarchical in the way they manage. So, but that's changing. The younger people that I found working at Reliance want to work more like they do in the US and Europe. They want to be part of a team. They want to be more open. They want to have challenging discussions. So when they find a manager that's open to that, they just leap right on it and participate. So, and I think that there's a lot of change in India that's happening, and it's to a large extent based on that it's becoming more open and from a team standpoint.
Yeah, interesting. That's a good perspective because I sometimes wonder. I think we face the same challenges around the world, and we have different approaches to them,
Yeah.
right? I mean, and that we can look at that for everything, and it sounds like it's a function of culture as much as it is education and experience.
Yeah. One of the board members at Reliance is Raghunath Mishelkar, and he was head of the CSIR, Council of Scientific Industrial Research in India. He's a very well-known guy, written a lot of articles. He wrote an article about research in India. I wish I could remember the name, but the gist of the article is that in Indian education, the bachelor's level is the best in the world. They do the best job producing bachelor's in chemical engineering and science.
Sure.
In an article, he said, but there isn't one Indian university ranked in the top 10 in the world at the PhD level. And he thinks the reason for that is that in the universities, the professor is the font of all knowledge. And the students tend not to challenge him. Well, when you're an undergraduate, they're teaching you type 2 problems. It's all well-known stuff. But at the PhD, you're trying to develop new solutions, new technologies. So the professor can't be the authoritarian. He has to be open to working with students. And again, I think over time that's changing. IIT Mumbai, other universities in India are improving their ability to turn out really creative PhDs.
Interesting. That's really cool. Well, good. Well, Pete, this has been really a great conversation, and I've really enjoyed it. If people want to learn more about Type 3 solutions and your problem-solving framework, how do they do that?
Well, the easiest way is for me to be crassly commercial and say that I've written a book about this topic called Type 3 Solutions. It's available on Amazon. And
I'll actually include the link for you, Pete. I'm okay with that.
Great.
Yeah.
Well, and the reason I wrote the book last year, and the reason I wrote it was, not so much to be a John Grisham #1 bestseller, because it's a pretty narrow audience, but I wanted to document the things I had learned over 50 years in the chemical industry about problem solving. And so part of that would be a legacy. Part of it may be there's some opportunity to help people in that regard. And the first part of the book talks about the general approach to solving type 3 problems, looking at the system, the functionality, abstract solutions, resources, generating ideas. How do you do that in general? And then the following chapters in the book talk about specific applications: manufacturing improvement, product development, product offerings, intellectual property development, business strategy, business processes. So you can read the first part of the book, which is 3 chapters, I think, and then just cherry pick after that, which subjects are you interested in? And whether or not you follow the exact method, you'll get some ideas about how to approach the problem.
Yeah.
And another interesting thing I found is when people use that approach, it actually increases their ability to think creatively. I'll give you a personal story.
Yeah.
I was watching television one day and I saw an ad for the topsy-turvy tomato plant. And so they show a tomato plant growing in a garden, and the tomatoes get big and the plant falls over, and bugs are crawling on it. And the guy has to go out and stake the tomato up. And the topsy-turvy tomato plant, you buy it, it's in a pot, and it's got a hanger, and it hangs upside down.
I've seen these.
Yeah.
I've never tried it, but I've seen them.
It grows upside down, and you never have to deal with all those problems.
Yeah.
Well, I saw that, and I thought, there's one of the innovation principles we use is in there, and that principle is inversion. And inversion says, can you do something upside down, backwards, inside out, and would that make a difference? So I thought, wow, I never would have thought of that in those terms of this is an example of inversion. So, and maybe one more, I had an Apple computer. When I first converted over from PC to Apple, my daughter, who's a teacher, said, I knew you can turn away from the dark side, Father. So anyway, Apple must not be the dark side. So I was working and I get a message that says, you should plug the computer in to avoid losing data. I had it plugged in. And then I looked and I noticed it wasn't charging the battery. Oh, wow. So I ran out to Best Buy. I bought a generic brand charger for my computer,
Right.
Plugged it in, and then a message popped up, said, your computer might not run at optimum performance. And I thought, well, what does that mean? After a while, I noticed that the brand X charger was not charging the battery. And I thought,
right.
Wow, why would
it's
they
a
do that?
lovely Apple conundrum.
So the underlying principle, one of the principles, is mismatching. It says to counteract harm, can you mismatch components in a system? And I thought, that's what Apple did. They mismatched the brand X power adapter and their laptop.
Yeah.
So the thing I find is when I see products or problem solutions, I tend to think of them in terms of what are the underlying abstract principles. And the better you get at doing that, the more creative you can be at solving new problems. So that's, I think, the big message about how I look at type 3 problems and solving them is you can teach yourself to be more creative and innovative if you learn to think this way.
That's awesome. That's very cool. Well, Pete, thank you so much for joining us today. I really appreciate taking your time and getting your insights here on The Chemical Show.
Well, thank you very much. And I'm happy to share this. As I said, at this point in my career, I'm primarily trying to do a little education, leave a legacy, but I'm happy to talk to anybody that has any questions or would like to discuss it.
Absolutely. Well, we will we'll get people connected to you on LinkedIn and with the book, and I'm certain you'll have a few follow-ups. So thank you for joining us today.
Thank you so much.
Absolutely. And thank you everyone for listening. Keep listening, following, sharing the podcast, and we will talk to you again next week.
We've come to the end of today's podcast. We hope you enjoyed your time with us and want to learn more. Simply visit thechemicalshow.com for additional information and helpful resources. Join us again next time here on The Chemical Show with Victoria Meyer.